When we get started into this complex number stuff, we really need to understand exactly what the difference between real numbers, imaginary numbers, and complex numbers are. Real quick, real numbers are numbers that pretty much you've dealt with a lot. Anything that doesn't have an I in it, pretty much. Let's see. So, like real numbers, examples would be like the number 17. It's just a regular old number. -5. Pi, even though it's 3.14 and then it just keeps on going after that, it's still a real number. It has a numeric value. Fractions are real numbers. You could have like 4/5. Square roots, you could have square root of 7. That's a real number. Anything, I mean, you could have 3.3 repeating. All those are real number situations. Imaginary numbers are numbers that are going to have an I with them. Right there, just that little I, which is equal to the square root of -1. Now, there's a lot of important reasons that we use I. We're not going to get into those just yet. Right now, I just want you to understand what imaginary numbers look like and the real numbers, and then again, the complex numbers. So examples of imaginary numbers is anything that's going to have an I with it. So it might be like a 2i or any other coefficient. -5i would be something that we would use for an imaginary. You might have I times the square root of 10. You might even have like a decimal, 7.3i, whatever. As long as it's got an I in it, it's going to be an imaginary number, or at least going to be the imaginary part of what we're going to call complex numbers. Complex numbers is when you put real numbers with imaginary numbers and you end up with binomials with them. And we put these in what they call A plus BI form, where A is the real part and then this would be the imaginary part. Whatever number you have with the I would be your B part. So we would have examples. We could have 3 plus 7i. That would be a complex number. 4 minus 2i. Then we would even have 5 plus I times the square root of 6. I mean, it doesn't really matter. The point is, the complex numbers is when you have both a real part and an imaginary part. And then in this case, this would be the real part. And then the imaginary part is the part with the I. So it's important that you understand that there's a difference there, because a lot of mistakes that people want to make is they want to call all your imaginary numbers complex numbers. That's not true. That's not how that is. Complex numbers have imaginary numbers in them, but they have a real part and an imaginary part. There's a difference there. So it's important that we understand that the real numbers, what they are, what the imaginary numbers are, and that it takes both to be imaginary or to be complex. So it's just real important that you understand that, because when we use that terminology, I need you to know what we're talking about. Now, the next part is where this gets confusing, and I made this a little bit smaller so I can write over here on the side. Complex numbers, even though they have both a real and imaginary part, there are cases where really these are technically going to be complex numbers, and these would also be complex numbers. Really what happens is complex numbers are going to basically encompass your real numbers and your imaginary numbers. The only difference being is that, let's use our 17 we got written over as a real number. If we had 17, then the real part of this number is 17. There's an imaginary part that would be 0 here. So let's say we had plus 0. Well, plus 0i. Then this is our imaginary part. We don't see that. You don't have to put plus 0i. The imaginary part's 0, so the real part is 17, so it looks like it's just a real number. And really, it is, but also it's included in complex numbers. Now, for our purposes, what we're going to use, most of our complex numbers we're going to be in this form. But what will happen is if we're doing math with the complex numbers, maybe we have 5 plus 3i minus 6 plus 3i. Well, what would happen is we'd have 5 minus the 6 is negative 1, and then 3i minus the 3i is going to be 0i. So 1 would be the result of that, or negative 1 would be the result of that, but really it's negative 1 plus 0i. So even though it's just the negative 1 that's left, or just the negative 1 that's left here, this whole thing is really what's being represented there. It's just with the 0i, they cancel each other out. So it's still technically a complex number, but it doesn't really have an imaginary part. The imaginary part is 0. So it does get a little bit confusing. The more we do of this, it's not going to be that bad, because the actual math of it is not that difficult to understand. It's just when you get into all these technicalities, it can be hard to understand what's a complex number, what's a real number. So the way that we're going to look at this, let's get rid of all of this over here. If we have numbers, let's say we have just real numbers. If we just have these real numbers here, then that falls under the category of real numbers and complex numbers. All right, if we have just the imaginary numbers, then it falls under imaginary and complex numbers. But if we have something set up that's in a plus bi form, where we've got like a real number part and an imaginary part, and they're both non-zeros, which means that you actually see them, 3 plus 7i, or 5 minus 2i. As long as there's a real part and an imaginary part that's not 0, then it's only going to be complex numbers. So complex numbers are going to include your imaginary numbers, and it's going to include your real numbers. But these types of numbers where you have a real and an imaginary are only going to be complex numbers. They're not going to be anything else.